Now it is 14th problem from 1997. A sample of gas expands from volume V1 to V2. The amount of work done by the gas is greatest when the expansion is adiabatic, equal in all cases, isothermal and isobaric. We know that at the time of isothermal process, no change in internal energy take places. So work done is maximum in the process isothermal. So we will go with option C. Next, an ideal gas at 27 degrees centigrade is compressed adiabatically to 8 by 27 of its original volume. The rise in temperature is, what things are given? If initial volume is V, final volume should be 8 upon 27 of V. Initial temperature 27 degrees Celsius means 300 Kelvin. We want, first we will calculate final temperature, then we will calculate rise in temperature means T2 minus T1. We know that at this time gas will follow Poisson's law, PV raised to the power gamma is equals to constant, but PV is equals to mu RT. We want to remove P, so we can write P mu RT by V into V raised to the power gamma. It is constant. It means now gas will follow V raised to the power gamma minus 1 into T is equals to constant, because mu and R are again constant. So what will happen now? V1 raised to the power gamma minus 1 into T, it should be equal to V2 raised to the power gamma minus 1 into T2. So what is T2? T2 means T1 into V1 upon V2 raised to the power gamma minus 1. T1 is given 300 Kelvin. V1 upon V2, if you divide V1 by V2, means V by 8 by 27. 27 we will take at this place V. Raised to the power gamma minus 1. Gamma is given 5 by 3. So what we are getting? 300. 27 by 8 means 3 by 2 cube. And power is 5 by 3 minus 1 means 2 by 3. Cancel 3 with 3. So square of 3 by 2 is 9 by 4. So what we are getting? 75 into 9. 675 Kelvin. So rise in temperature means 675 minus 300. So we got the answer 375 Kelvin. So we are going with B. 16th. In thermodynamic process, which of the following statement is not true? In an adiabatic process, the system is insulated from the surrounding. It is true. In an isochoric process, we know that in isochoric process, volume remains constant, not pressure. Pressure remains constant only in isobaric process. So it means statement B is wrong. So we are going with B. An ideal Carnot engine whose efficiency is 40% receives heat at 500 Kelvin. If its efficiency is 50%, then the intake temperature for the same exhaust temperature is, this problem they asked in a 1995 AIPMT. We know that what is the formula for efficiency? 1 minus T2 by T1. What was the efficiency? 40%. Means initially it was 40 upon 100. 1 minus. What they are saying? The Carnot engine receives heat at 500 Kelvin. It means it is the temperature of source. And he exhausted heat at temperature T2. Now efficiency is 50%. They are saying for same exhaust temperature, means same T2, what should be the temperature of T1 now? So what we will do, we will calculate T2 from this first. T2 upon 500 is equals to 1 minus 40 upon 100, means 60 upon 100. Cancel 20 with 20. We are getting the temperature of sink 60 into 5, 300 Kelvin. Now in this 50 upon 100 means 1 by 2 is equals to 1 minus T2 by T1. So T2 by T1 is equals to 1 minus 1 by 2 means 1 by 2. So T1 is equals to 2T2. We got T2 300. So T1 should be 600 Kelvin. So we are going with option C. Next, the efficiency of a Carnot engine operating with reservoir temperature of 100 degrees Celsius and minus 223 degrees Celsius will be. They asked this direct problem in the exam 1997. What is given? We know that formula for efficiency 1 minus T2 by T1, or you can say T1 minus T2 by T1. We are using capital letters T1, it is T1. It means temperature should be in Kelvin. So what is given? T1 is given 100 degrees centigrade. So to convert in Kelvin, we have to add 273. So it is 373 Kelvin. What is T2? Minus 23 plus 273 means 250 Kelvin. So we can write this efficiency is T1 373 minus T2 250 divided by T1. T1 is 373. So 373 minus 250 by 373. So we are going with option B. Next, the W upon Q of a Carnot engine is 1 by 6. What is W upon Q? Useful work upon energy intake. It means they are talking about efficiency. So what is given? Initial efficiency was 1 by 6. When the temperature of sink is reduced by 62 degrees centigrade, the efficiency becomes twice, means new efficiency is twice of this, means it should be now 1 by 3. Therefore, the initial temperature of the sink and source are respectively. C. Let initial temperature of source was T1 and sink was T2. We know the formula for efficiency. 1 minus T2 by T1. 1 minus T2 by T1. What we are saying, initially it was 1 by 6. it will become 1 by 3 when we decrease the temperature of sink. It is T1 means source and T2 means sink. We know that change in temperature for both scale is same. It means if you are saying I am reducing temperature by 62 degrees centigrade, we also can say that we are reducing the temperature by 62 Kelvin. For Kelvin scale and degree Celsius scale, I told you initially that change for these both scale is same. It means we reduce the temperature of sink by, we can say 62 Kelvin divided by T1 means 1 by 3 is equals to 1 minus T2 by T1 minus minus plus 62 by T1. Now we are putting the value of 1 minus T2 by T1 from 1 in 2. So from 1 we can write it 1 by 3 is equals to 1 by 6 plus 62 by T1. So this implies 62 by T1 is equals to 1 by 3 minus 1 by 6. So it should be, it is 2 by 6 minus 1 by 6, 1 by 6. So T1 means 372 Kelvin, or you can say 99 degrees Celsius. It is 99 degree Celsius. Only in one we are getting this source 99. So no need to calculate for any other option. So we are getting 99. After putting T1 in any equation, in this equation, you will get T2. So we are going with option B. It is from 2001 AIPMT. A scientist says that the efficiency of his heat engine, which operates at source temperature 127 degrees Celsius and sink temperature 27 degrees Celsius, is 26%. Which statement can be correct? See, first we will check for these two temperature what is the efficiency of ideal heat engine, means Carnot heat engine, in which we were using infinite thermal capacity source and sink, in which we were using ideal gas as a working substance. They are saying temperature of source means T1 127 plus 273 2131 400 Kelvin. Temperature of sink 27 plus 273 300 Kelvin. So efficiency of ideal Carnot heat engine working with this temperature, it should be 1 minus T2 by T1 means 1 minus 3 by 4 means 1 by 4. In percent it is 25%. It means for ideal heat engine working with this temperature, efficiency is 25%. So for any real heat engine, it cannot cross it, means it is quite impossible. So we are going with A. With these two temperature, efficiency of ideal heat engine is 25%. So for any real engine, it should be less than 25%. So we will take A. Next, the efficiency of Carnot engine is 50%. Temperature of sink is 500 Kelvin. The temperature of source is kept constant. Efficiency we want 60%. required temperature of sink will be, same type of problem is again there. It is from 2002 AIPMT. We know the formula of efficiency, 1 minus T2 by T1. What they are saying, efficiency is 50%, means 50 upon 100. The temperature of sink was 500 Kelvin. Source not given. Temperature of source they want to kept constant, but we want now efficiency 60%. We want source at same temperature but changed T2. So we are going to calculate T1 from this equation. 500 by T1 is equals to 1 minus 1 by 2, means 1 by 2. So it means T1 should be 500 into 2000 Kelvin. So now 6 by 10 means 3 by 5 is equals to 1 minus T2 by 1000. So T2 by 1000 is equals to 1 minus 3 by 5, means 2 by 5. So T2 should be 2 by 5 into 1000, means 2 into 200, means it should be 400 Kelvin. So we are going with C. So it was 21st problem.